place where I've typed in f of x equals x squared plus 3. This is a nice quadratic. So this relation here, if you have a look at this quadratic, it's x squared plus 3. It's definitely a function. It passes the vertical line test. You might think, well, what type? Is it a one to many? Is it a many to one? Is it a one to one? Okay, so from those three, you can have a little think about that. And I just want you to see that I actually then worked out the inverse relation to this. I took this y value, subtract 3, then square rooted. And then I created the inverse here, which is this pink. And look, the 1, 4 on here, on this function, that actually pings across to 4, 1. So all the inputs, outputs, domain range here becomes the other way around on the pink function here. Okay. Now at the moment this is a function, but of course I've got this particular branch missing. So all of this kind of U shape here, this parabola, should come down here and beautifully curve down here. Now we can do that by going to Control G. What we've got is we've got to take the negative branch of the square roots. This is negative f4 of x, and that will put in that beautiful branch there. Now can you see that this particular quadratic is a function, right? But when we do the inverse and plot the full part, this inverse is not a function. Okay, so we start here with a quadratic. This quadratic relation becomes this square root relation. This quadratic is a function, but this inverse quadratic is not a function. Okay, so that's kind of an important idea. We can easily turn this guy here into a function as long as we kind of get rid of the doubling up of outputs. Yeah, so for each of the x inputs, we're hitting 2 outputs. We only want there to be 1 output. So we can do that by restricting the domain. So if I actually go up to this guy here, now the restriction domain comes with control equals, and it brings you up that blue little menu. And it's this little slash here, given that, that's what it says. Now I'm going to restrict the domain by doing, I don't know, x, let's have a look, greater than or equal to, I'll do -2. Does that help me? Okay. I don't think it does help me because can you see that this point here, if I do Control T for the table of values, can you see that the quadratic is undefined beyond -2? So I've got -2, 7 here, -2, 7. Okay, so if I do Control T again, this point here, if I do menu, trace, graph trace, let me just bring that up here. Oh, I didn't like that. Okay, there we go. So if I do graph trace and just bring that point down, okay, it goes up to here, and at the end of the point here is actually -2, 7. That graph trace wasn't that successful, was it? Okay, let me just go back and get the nice function here. So this point here is actually -2, 7. So where does that go? It goes to 7, which is along here, 7, -2. Okay, so we get this kind of curvy branch here. So by restricting the domain of this quadratic here, we've got this, but this guy here then would get reflected over to about here. And so we've still not managed to turn this into a function. It's still only a relation. So you want to think about the interplay between the two. This is the original. It's a function. But when we kind of reflect it, we get this bit and we get to here. And I can actually change this picture into something really nice because what I can do is change it. And I can put, let's see, control, given that. So now we need to think about, well, how do I restrict this little part of it? So I think I need to have, given that x is, let's think about it, I think it's less than or equal to 7. Should we try that? Beautiful. Can you see that perfect symmetry down the orange line there? So this section here gets reflected down here. And this section here gets reflected here, okay? So yeah, we haven't quite turned this into a function yet, but you can get the idea that if we restrict this still further, the domain, and we have x is greater than or equal to 0, that's better, isn't it? We've turned this now into just one branch here, and if we change this one, and we just delete this branch altogether, and we delete this brown part, now we have the inverse relation is indeed a function. So have a little think carefully about that, about domain restrictions, about the idea of relations being one-to-one or one-to-many or many-to-one, and how that impacts the relationship between the function and its inverse, and whether this inverse can be classified as a function or not. Okay.